Okay, hello students. In these sessions, I will introduce you new keywords in C++, which is override and final. And I will also introduce you about the concepts of abstract class. And in the last session, we studied why we should use our virtual functions. But in this session, I will talk a little bit about the disadvantage of using our virtual functions. So let's start. First, let me introduce you the override keyword. Override keyword is newly introduced in C++. C does not have this. The override keyword has two advantages. First, it prevents programmers' mistakes. Second, it improves the readability of your program. For example, discount sale class, which is a child class of sale class. You do not know which member functions are virtual and which member functions are being overridden by just looking at the derived class. So if you look at this example, the bill is a virtual functions because there is a virtual keyword. But bill member function here also virtual functions because it inherits this bill member function here. But by just looking at this derived class, the discount sale, you have no idea whether this bill is virtual or non-virtual member functions. But if you explicitly specify the override keyword, like this example, now it is clear that which member functions are being overridden in the derived class. So it is clear now that you are overriding the bill member functions here. In addition to that, you know which functions are virtual functions by just looking at this derived class. If you use an override keyword on a function that is not virtual, the compiler will throw error message. So you can only use a virtual, override keyword on a virtual function. So by looking at this keyword, you know which functions are virtuals and non-virtual. Using override keywords also prevents programmers' mistakes. For example, in order to achieve polymorphism, the derived class should override the inherited virtual functions from the base class. So like this example, the derived class must override these bill virtual functions in order to provide the polymorphisms. But even the programmer's intention was to override the inherited virtual functions, programmer may accidentally override non-virtual member function by mistakenly writing wrong function signatures. Such mistakes can be prevented if we use the override keyword. Let's look at the demo code for the override keyword. So this is the demo code for using override keyword. It has a two class A, and class B. Class B inherits class A, and there is one virtual function, print is virtual functions, and there is one member function, print, in B class as well. And inside of these main functions, we create A classes types of objects and B classes type object and pass that object to these test functions. And these test functions print call the print member function based on these arguments. What is the expected output of the program? Here, the intention of the developer's intention here is the providing polymorphism. So we learned this polymorphism in last sessions. Depending on the argument, the type of the value stored in this variable, the different print member function should be invoked. So that is the polymorphisms. And because we are passing type A and type B types of object to these test functions, the first time the programmer's intention is that at first core of this test, programmer's intention is to call the print member function in class A. For the second test function call, the programmer's intention was to call the print member function in class B. Let's compile this program and see whether program produces expected output. There's no compiler error, and if we run this program, this is the output of the program. The no compiler error prints here, but for the first test function call, it prints A, so it calls the print member function in class A. And for the second function test call, it also calls the print member function in class A, not B, even though we passed the type of class B. So this is not expected result. So why this is happening? Why the second test call does not link to the print member functions in class B, even though we passed the type of class B's objects. The reason for this unexpected behavior is that programmer mistakenly overwrite wrong member functions. So if you look at here, print without no argument is a virtual function, but in the derived class B, we are overriding the print with one int type of parameter. So the programmer's intention was the overriding this void print member functions, but here because programmer mistakenly put these arguments, they are not overriding the virtual functions. They are just declaring new print functions which receive one argument. So that is the reason why as second call of these test functions, print member function in class A was called because there's no arguments passed here. So to fix this problem, you you need to remove this one, and if we compile again, now program produce expected output. First, it calls a member function in A class, and second, it called a member function in class B. How can we prevent such programmer's mistakes? Let's go at this one. How can we prevent this? If we use a overwrite keyword here, like this, do you think this program compiles well? Because let's compile this program first. Because overwrite keyword is newly introduced in C++ 11, so I specify the versions here. I compile this. The compiler saw our message saying that non-virtual member functions mark override. So you cannot use the override keywords with the non-member functions. So because of this compiler error, now you can see that you are mistakenly overriding wrong virtual functions. So now if you do this, now compiler does not complain about anything. If we run it, and program also produced the expected output as well. So overwrite keyword improves your program's readability. So there's no virtual keyword here, but by looking at this overwrite keyword, you know this print member function is a virtual, not even though you do not look at this base class. By just looking at this class, you know that this member function is a virtual because of this override keyword. And this override keyword will prevent you from overriding wrong virtual functions, as we saw in this demo code, by throwing the compiler error, because we can only use this override keyword in our virtual functions. Okay, so that's overwrite keyword. Let's go back to the slides. Now let me introduce you another keyword, which is final. In some case, you might not want derived class to override the base class's virtual functions. So to enforce that, the keyword final is introduced in C++ 11. If you specify final keyword like this, the derived class cannot override these virtual functions. The attempt to override such virtual functions leads to the compiler error. And because this bill is the final, if you do override this, the compiler will show error message. And similar to override keyword, you cannot use these final keywords on non-virtual functions. So you can only use these final keywords on virtual member functions. Okay, so let's see the example code for this final keyword. This is the demo code for final keyword. Like a previous example, there's two classes, class A and class B. Class B inherits the class A. And as you can see here, there is a final keyword in the print virtual member functions. In class B, it overrides the print virtual functions. And inside of this main function, we are declaring class A variable and class B variable. Do you think this program leads to the compiler error? Let's compile this program. Yes, this program leads to the compiler error. Compiler error saying that declarations of print overrides the final functions. So the class B is a derived class. It inherits the class A, but print is marked as final, so you cannot override this print virtual function in the derived class, but in class B, it's trying to override these print member functions. So the compiler error occurs here. If you remove the final keywords here, the program will compile well. So as expected, now program compiles well. And you cannot use a final keywords in non-virtual functions. So this one is a non-virtual functions. If you use a final keywords in non-virtual functions, the compilers are complaining about it. It's saying that only virtual member functions can be marked final. So you cannot do that. And if you put the final keyword here, you can override the final virtual member function in a derived class like this one. So that's final keywords. Let's go back to the slides. Okay, now let's talk about the disadvantages of using virtual functions. There are clear advantages of using virtual functions because it provides runtime polymorphism, as we learned in the last sessions. Then why C++ does not make all member functions virtual? You know Java. Java is also a popular object-oriented programming language. Every non-static method in Java is a virtual function, except for final and private method. So Java automatically makes member functions virtual because virtual function gives a lot of advantages. But why C++ compiler does not make member functions virtual automatically like a Java programming language? The reason for that is overhead. If you use a virtual functions, your program will use more memory in order to store something called vtable. Vtable is a virtual function table. It stores all the information of the virtual functions. For example, it stores the where the virtual function is located in the memory. C++ compiler uses these vtables to perform late binding. We learned about the late binding in the previous sessions. And because of this, your C++ program will use more memory if you use the virtual functions. And a late binding is slower than the static binding. Static binding is a compile time binding. So if you use a lot of virtual functions, your program's performance will degrade. These are the reasons that C++ does not make all member function virtuals automatically, because C++ uses often for developing embedded systems, so such systems performances are critical. So unlike Java, C++ does not make member function virtual automatically. It is programmer's decisions when to use virtual functions. Okay, let's talk about the pure virtual functions. What is it? What is pure virtual functions? Sometimes it is not possible or meaningful to provide the implementation of core functions in a base class. For example, recall the figure example in the previous sessions. In the last sessions, we designed the figure class, which is a base class, and we also designed rectangle, circles, and triangle class, which inherits this figure class. And there was a draw member function, which draws the figures on your screen. It is clear how to implement draw functions for rectangle, circles, and triangle, but it is not so clear how to implement draw functions for the figure class. In such cases, you can make pure virtual functions. For the pure virtual function, you do not need to give the definition of the functions. And you can make the pure virtual function using equal zero sign like this. So this is how you make the pure virtual functions. You specify the virtual function signature, and instead of putting the function body with a bracket, just assign to 0. 0 indicate this is a pure virtual functions. By doing this, you don't need to give a definition of the functions. So like Shown here, pure virtual function require no definitions. And if a class has one or more pure virtual functions, then we call that class as an abstract class. An abstract class can only be used as a base class to derive other classes, and you cannot create objects of an abstract class because the implementation of some virtual function is missing. The derived class must override and provide the definitions of all the pure virtual functions. Otherwise, the derived class will itself be an abstract class as well. If the derived class do provide definitions for all pure virtual functions, then the derived class is not an abstract class anymore, so you can create objects of that class. So let's look at the demo code for these pure virtual functions. Okay, if you look at this program, we have two classes. The first class is pet, consists of the string, name, member variables, and one member function, which is a virtual function. And this virtual function is a pure virtual function because we assign 0, like this. And there's another class here. The class name is a dog. It inherits the pet class. And it also has a member variable for breed. And it overrides the print virtual function. We know this is a print. This is a virtual function because we use the overwrite keywords here. We can only use overwrite keywords on the virtual functions. And this is the definition of this print member functions. It just prints this member variable. And inside of the main function, we declare the dog class variable and pet types of class variable, and assign the name and breed member variable, the value, and use the print member function in dog class. Do you think this program compiles well? It looks fine because pure virtual function is overridden here. What do you think? Do you see any problem in this code? Let's compile this program. Okay. Compilers complaining about something. The compiler saying that variable type pet is an abstract class. Unimplemented pure virtual function printed in a pet. Okay, so basically the compiler saying is that there is an unimplemented pure virtual function print, which is this one, in a pet class. So the pet is an abstract class, saying here, and you cannot declare the variable or create the objects of this abstract class, but it's saying that we are trying to create the object of this abstract class, so it's here. The compilers are complaining about this line. So basically this line creates the objects of class type pet, but pet class type consists of pure virtual functions, and because of that, pet is an abstract class, and I said that we cannot create the object for the abstract class, so compilers are complaining about this line. So if we remove this line, compiler should not complain about anything. This program should compile as well. Let's compile this one. As expected, this program compiles properly, and if we run this one, it prints this line because we call print member function here. So this is the expected output of this program. Okay, so that's it for these sessions. In the following sessions, we will talk more about the virtual functions. Especially, we will talk about the slicing problems when we are using virtual functions. Okay, see you in the following sessions.